Welcome to IT Career Institute. Hi, I'm Orna Sharkar, and today in this video I'll be discussing the solutions of WEBJEE 2022 chemistry paper. And this video will not only be helpful for all the students who already have appeared, but this solution will come quite handy to all the students who will be appearing in 2023 WEBJEE and in any other competitive exams that will be held in coming year. So let's start. Let's start with the first question. The first question given is, let me read it out. A sample of magnesium carbonate is dissolved in dilute HCl and the solution is neutralized with ammonia and buffered with ammonium chloride, ammonium hydroxide. Disodium hydrogen phosphate reagent is added to the resulting solution. A white precipitate is formed. So we have been asked to answer what is the formula of the precipitate. You have been given 4 options. So let me start with the solution. See, in the first line, what is it telling? A sample of magnesium carbonate is dissolved in dilute HCl. So the first reaction will be between magnesium carbonate and dilute HCl. Yes. So let me write the first line and make space for writing it. So magnesium carbonate plus dilute HCl. This is our very known old double decomposition reaction. Here, what will be the product? MgCl2. See, the cation and anion part are exchanging their places, nothing else. MgCl2 plus H2CO3. Now, in this, ammonia was added, right? So, when ammonia is added, ammonia is a base and this is carbonic acid, it is acidic in nature. So, basically ammonia will be reacting with carbonic acid. So, magnesium chloride will remain as it is and carbonic acid will be reacting with ammonia, resulting in the formation of ammonium carbonate. Next, they are talking about providing buffer. Okay, so buffer is added, there won't be any reaction, it is just added to maintain the pH of the solution. So the buffer is added to maintain the pH of the solution. Now in this disodium hydrogen phosphate Na2HPO4, this reagent is being added. Now this will complex with magnesium and ammonium, resulting in the formation of MgNH4PO4. And this option is given, this is your B option, so this will be the correct option. So what is the formula of the precipitate? This is the answer. Okay, so let's move on to the second question. Here in this question, we have been asked HCF2, NO2, HCl, ClO2 and CO2. So we are given 5 compounds and we are asked identify the non-linear molecule pair from the above mentioned molecules, and there are 4 options given. So among these 4 options, among these 4 pairs, which of the 2 compounds basically are non-linear? This has been asked to us. So for solving this problem, we need to know certain rules. Okay, certain rules for solving this question. Basically, there are certain rules how to basically calculate the structure of a compound. There's certain tricks for solving that. Let us start with HCF2, the first compound that is given to us. First, we have to find out the central atom. Now, Hc here is the central atom. Okay. Now, number of valence electrons of Hc, that is 8. That should be written first. Plus, how many elements are attached to Hc? 2 fluorine. So, we have to add up 2 for that. This will come out as 10. Now, whatever the value comes up, that will actually help us to predict what is going to be the structure. For example, this is basically a chart through which we can predict if after calculating 4 comes, then the structure is basically linear. If after calculating in this way, if it comes 6, then it is trigonal planar. If it is 8, then it is tetrahedral. If it is 10, then it is trigonal bipyramidal. If it is 12, then it is octahedral. So this way, if 4, 6, 8 or 10 or 12 comes up, likewise we can predict their corresponding structures. Now HCF2, for HCF2, what's the value? 10 has come up. So basically it will assume trigonal bipyramidal structure. In short, we can write it down TBP. So how will it basically looks like? Now from Bend's rule, we already know that the more electronegative atom basically occupies the axial side. So fluorine being more electronegative will be occupying the axial side of the trigonal planar geometry, and there will be other 3 lone pairs. Now these 3 lone pairs will be occupying the trigonal geometry of this trigonal bipyramidal structure. So basically this is the structure. Now if I omit the lone pairs, because these lone pairs are basically not the elements that are forming the compound are HCF2. Now they are forming in a straight line, so they are basically assuming the linear geometry. Now there is quite a good difference between geometry and structural structure. See, this is the trigonal bipyramidal structure, but we are asked we have to find out the geometry. So basically after omitting out the lone pairs, the geometry that is being assumed by HCF2, that is basically linear. Next, let's move on to the next one, NO2. Here the central atom is nitrogen and number of valence electron, outermost shell electrons of nitrogen is 5. Now there is one more trick. If there is oxygen, then for oxygen it is divalent and it forms a sigma bond as well as a pi bond, right? So for sigma we have to do +1 and for pi we have to do -1. So basically these are certain tricks by which we can calculate the structure, you know. And then 1 - 1, and how many oxygen are there? 2. Now 1 - 1 is ultimately 0. So what will be the end result? That is 5. Now you will be thinking that 5 is not mentioned in this chart. Then what we will basically do? Basically NO2 has been found to form dimer N2O4. They exist as a dimer in dimer state. So 5 + 5, there will be one unpaired single electron present over the nitrogen, and this will bond with another nitrogen's single electron that will be situated on another nitrogen, and they will form a dimer basically. Okay, so see, 5 is coming in between 4 and 6, right? So this will be the basic structure of N2O4, which is non-linear, correct? Next we will move on to HCN, which is the central atom carbon. Number of valence electrons of carbon 4. Now which is what are the two other elements attached to it? Nitrogen and hydrogen. Just like oxygen had a trick, here nitrogen also has a trick. Nitrogen, whenever it bonds with any element, it forms triple bond, right? One is sigma, other two are pi. So for one sigma +1 and for other two pi there will be -2. And again for hydrogen there will be +1. So 4 - 1 +1, ultimately -1 +1 will be 0. Ultimately you are getting 4, and for 4 we can predict the structure to be linear. So HCN basically has a structure like this. So it's a linear structure, it's not non-linear. Okay, and the last one we are left with is ClO2. Number of valence electrons of fluorine 7, plus oxygen. For that oxygen, 2 bonds, it forms 2 bonds. So one is sigma for that +1, another is pi for that -1 into 2. So ultimately this is 0. So the result is coming 7. Again 7, it's not in this chart, so we cannot predict directly from this chart. So basically ClO2 like NO2 also form or exist in dimer state, Cl2O4. And how does the structure looks like? This basically exists like this. Okay, so this is also non-linear. So finally, which two options are coming out as non-linear? Cl2O4 and N2O4. Basically NO2 and ClO2. Which is the correct option then? D is the correct option. So this is how this question is need to be solved. The third question is the number of atoms in body-centered and face-centered cubic unit cell respectively are. 4 options are given. So basically this question is from the chapter solid state. So let me explain it to you how is it, which will be the correct answer. So let's draw a cube first. Basically all the unit cells are in the form of a cube and we are talking about cubic unit cell only. So let us draw a cube first. For a body-centered cube, what do we know? Both body-centered and the face-centered unit cells, both of them have the primitive structure. What do I mean by primitive structure? That each of the corner will have 1 atom each. Now each of these atom at the corner is shared by 8 unit cells surrounding this cube. So what is the contribution of one of this atom to this unit cell? That will be 1 by 8, and how many atoms are there in total? 8 atoms. So that will be into 8. So total contribution, total effective number of atoms will be 1. This is the primitive structure. This is for primitive structure which is present in both face-centered and body-centered. Now in body-centered there is an additional atom at the center, and that atom is wholly present inside the cube. So what is the contribution of that atom to this cube? That will be 1. So plus that will be another 1. Overall total 2 atoms, total effective number of atoms that is present in BCC, that is body-centered cube, will be 2. Similarly, for face-centered cube, similarly the primitive structure, for the primitive structure that is for the 8 atoms present at the 8 corners, the contribution of each of these atoms will be 1 by 8 into total number of atoms present at the total 8 corners is 8, that equals to 1. And in face centered, each of the faces has 1 atom each. So how many faces are there in a cube? Total 6, correct? Total 6 atoms are present. Total 6 atoms are present in FCC. Now each of these atom is contributing only half, because this atom is being shared by another cube adjacent to it. So this atom, the contribution of this atom to this cube is half. So half, and how many such atoms are present? Total 6. So half into 6, that will come out as 3. So total the contribution is 1 plus 3, 4. So for FCC it is 4, and for BCC it is 2. Now which is the correct option? That is 2 and 4. So the correct option is A. So the question 4 is the number of unpaired electrons in Mn2 plus ion E. So we have to calculate how many unpaired electrons are there in Mn2 plus. So for that, first we have to draw the electronic configuration of Mn2 plus. Now what is the atomic number of manganese? The atomic number of manganese is basically 25. So what will be the number of electrons in Mn2 plus? So we already know the atomic number means number of protons, that is equal to the number of electrons. So number of electrons basically in manganese is 25. So how many electrons will be there in Mn2 plus? So 2 electrons have been removed, so it will be 23. So for Mn2 plus, the electronic configuration will be written as argon 3d5. Why I have written argon? Because for electronic, for the elements having atomic number greater than 18, we can write the electronic, we can write the noble gas metal first. So the last noble gas which has the configuration of 18 is argon. So basically what does this signify? That is the electronic configuration of argon will be same to as the first part of Mn2 plus. Okay, and where does argon stops? At 3p6. At 3p6. So after p orbital, which orbital comes up? D orbital. So where will the next electrons come up? It will come up into d orbitals. Okay. Now how do we draw the box diagram of d orbital? How many rooms are there in the box of d orbital? 5. So 1, 2, 3, 4. So how many rooms? 1, 2, 3, 4, 5. Now according to Hund's rule, we have to first singly fill all the rooms each. We have to singly fill them. Once they are all singly filled, then only we can doubly fill them. We cannot start with 2 electrons in one of the box right? We cannot do that. We have to simply fill each of these boxes and then we can start with again with the first D1. So this is basically for D5. So all the electrons will be singly put into each of this room. So all the 5 electrons have been put up into this room. So how many unpaired electrons are there? All of these 5 electrons are unpaired. So basically there are 5 unpaired electrons. That has been asked to us in the question. So which is the correct option? Option C. So this is how you should solve this type of questions. So our fifth question is the average speed of hydrogen at T1 Kelvin is equal to that of oxygen at T2 Kelvin. We have to find the ratio T1 is to T2 and we have been given 4 options. So first of all, how to find out the average speed? What is the formula of average speed? Average speed equals to, it is basically denoted as U bar, that equals to root over of 8R capital T pi capital M, where R is the gas constant, T is the temperature at which the average speed has been measured, and capital M is the molecular weight of the gas under consideration. So what is the first gas that we are talking about? Hydrogen at T1 Kelvin. So mu bar for hydrogen will be root over 8R, its temperature is T1 pi, and what is the molecular weight of hydrogen? That is MH2, that will be 2. So let's write it down. Let's put the values of, that is pi into 2. Now what is the value of, what is the average speed of oxygen? The next gas under consideration is oxygen at T2 Kelvin. That will be root over of 8R capital T2 pi MO2. Now what is the molecular weight of O2? Oxygen atom is 16. So O2 will be 16 into 2, 32. So 8R T2 pi into 32. Now in this question it has been said that the average speed of hydrogen at T1 Kelvin is equal to that of oxygen at T2 Kelvin. So we can equalize these two. So basically in our question, mu bar of hydrogen is basically equals to mu bar of oxygen. So what was mu bar of hydrogen? What did we get? 8RT1 2 pi. 8RT1 2 pi. That equals to mu bar of oxygen. What did we get? Root over of 8RT2 by 32 pi. So let me rub this lower portion. So basically now we have to solve this. So squaring both the sides, we will remove the square root. So squaring both sides will remove the square root. So we will get 8RT1 by 2 pi, that equals to 8RT2 by 32 pi. Now pi from both the sides will cancel out, 8R will cancel out from both the sides. We will be left with T1, T2 and 2 and 32. So let me continue here. T1 by 2, that equals to T2 by 32. So T1 by T2. Let me bring T2 here. So T1 by T2 and 2 will come up here. So 2 by 32. That will come out as 1 by 16. So T1 is to T2 is coming out as 1 is to 16. Unfortunately, none of the option is 1 is to 16. So basically all this question, because none of this option is correct, so this question will carry grace marks. So this is a good news for whoever has attempted. Whether it's correct or wrong, you will be getting a grace mark for this question. So question 6, it's a very straightforward question. So what is the chemical formula sodium nitroprusside? Sodium nitroprusside is what? Out of these 4, which is going to be the correct option? So it is basically Na2FeCN5NO. So basically for this purpose you should remember some of the chemical formula of some of these important chemical reagents that are usually used. Okay, so this is our 7th question. Choose the correct statement for NiCN4 2 minus complex ion. So this is a question from coordination complex chapter. The atomic number of nickel is given to you. There are 4 options. In all the 4 options, either of these combination will be correct. So basically you have to find out whether it is paramagnetic or diamagnetic, and the structure is whether it is square planar and tetrahedral. Now for finding out such questions, first of all you have to write the electronic configuration of nickel. Now to save your time, I have drawn this entire set beforehand so as to save this time and not make this unnecessarily lengthy. So see, the electronic configuration of Ni28 is argon 3d8 4s2. Now for the pure nickel atom which doesn't has any charge, how will the electron be filled up? See, I am filling up first of all D. First I am filling up singly according to Moore's rule, then I am refilling starting from the beginning. So 5, 6, 7, 8. 4s has 2 electrons, 4p has none. So if 2 electrons are removed, then Ni2 plus will be generated, right? So 2 electrons will be removed from 4s, correct? So 3d will be left only with its 8 electrons in the configuration of Ni2 plus. So this is the box diagram for Ni2 plus, this is the box diagram for Ni atom. Now Ni2 plus in presence of Cn minus, what will happen due to the strong pulling character of Cn minus? These 2 electrons, this 1 electron will be shifted into this box, thereby pairing up this electron. So what will happen? This way the 8 electrons will pair up because of the presence of Cn minus. Mind it, due to the presence of Cn minus, this phenomena is occurring, that is the electron is shifting into and pairing with its adjacent electron in the adjacent suborbital. And these 3d, this 1 3d space 4s and 4p will undergo dsp2 hybridization. Will undergo dsp2 hybridization, resulting in the formation of 4 equivalent dsp2 orbitals. Now each of these 4 equivalent dsp2 orbitals will combine with 4 Cn minus. See, in this complex there are 4 cyanide ions. Now each of these cyanide ions will contribute 2 electrons. Overall 4 cyanide ions will contribute 4 pair of electrons. So these 4 pair of electrons will be basically bonding with the nickel's dsp2 hybrid orbitals. They will be those 4 pair of electrons will be accommodated in the vacant dsp2 hybrid orbitals that is being created in presence of Cn minus ion. So see, at the end of this configuration, and in this there will be, as it was before, these electrons are not hampered at all. It will remain as it is. Okay, this d orbital, the 4 pair of electrons will remain as it is, and these are the 4 pair of electrons coming from Cn minus ions, 4 Cn minus ions. So at the end, what is the resulting configuration? The resulting configuration is that all the electrons are paired. So we know the criteria for determining paramagnetic and diamagnetic. For paramagnetic there must be at least 1 unpaired electron, and for diamagnetic there must be all the electrons must be paired. So in this situation all the electrons are paired, so it is diamagnetic. It is basically diamagnetic. And Ni2 plus under the influence of cyanide forms square planar structure. It forms square planar structure. So this is basically the structure of NiCN whole 4 2 minus, and it is diamagnetic in nature. So which is the correct option? That is option C, square planar and diamagnetic. The complex is square planar and diamagnetic. Option C is the correct option. 8 that is given to us is the boiling point of water is higher than liquid hydrogen fluoride, and we have to write the answer for this. We have to find out the answer behind this statement. The options are: hydrogen bonds are stronger in water, hydrogen bonds are stronger in HF, hydrogen bonds are larger in number in HF, and hydrogen bonds are larger in number in water. Now to answer this question we have to know basically how does hydrogen bonding takes place in water and HF respectively. So basically what is the structure of water? The this is the structure of water where there are two lone pairs of electrons over this oxygen atom. Now we know hydrogen bonds form between an electronegative atom with that of a hydrogen, right? So here the electronegative atom is oxygen, but it has two lone pair of electrons. Now with these lone pair of electrons, it will form a hydrogen bond with another molecule of water like this. This lone pair will also form a hydrogen bond with another molecule of water like this, where the hydrogen bond is basically forming between the electropositive hydrogen atom and the lone pair of lone pair of this oxygen atom. Another lone pair of this oxygen atom is pairing or forming bond with the hydrogen atom of another molecule of water. Similarly, this hydrogen atom of this water molecule will form hydrogen bond with the lone pair of another molecule of water. And similarly, this hydrogen will also form a hydrogen bond with the lone pair of oxygen atom of another molecule of water. So overall, one molecule of water is basically forming 4 hydrogen bonds. 4 hydrogen bonds are found in one molecule of water molecule. And hydrogen fluoride, see, this is the structure of hydrogen fluoride. So the fluorine atom will be forming hydrogen bond with the hydrogen atom of another molecule of hydrogen. So this is how it's forming with its adjacent molecule, the hydrogen bond between fluorine and hydrogen. Similarly, this fluorine will again form hydrogen bond with another molecule of hydrogen fluoride. This fluorine will form another hydrogen bond with another molecule of hydrogen fluoride, and it continues. So basically, one molecule of hydrogen fluoride is capable of forming 2 hydrogen bonds. 2 hydrogen bonds. So let's now tally this reasoning with these options. The first option was hydrogen bond is stronger in water. The second option is hydrogen bond is stronger in HF. Now we cannot compare the hydrogen bonds. Here both of the hydrogen bonds are equally strong. So option A and option B gone. Now option C and option D. Now where the hydrogen bonds are greater in number? In water. So which is the correct option? Hydrogen number are larger in number in water. So D is our correct option. Question 9 is the metal that can produce nascent hydrogen in alkaline medium is. So what is nascent hydrogen? We all know hydrogen is more stable in diatomic state, right? So hydrogen, when it exists singly or in atomic state, it is quite unstable. It's like not very stable. So nascent hydrogen basically stands for singly hydrogen, which is not in its diatomic state, and it is always written in the third bracket. So this is a very straightforward question. Basically these 3 elements, generally these 3 elements like sodium, when it reacts with ethanol, C2H5OH gives just a second, C2H5ONA plus a nascent hydrogen. When aluminium reacts with sodium hydroxide, then it gives you Na2AlO2 plus, this will be 2 nascent hydrogen, and zinc in dilute H2SO4 medium. Just a second, this won't be dilute H2SO4 medium, this will be alkaline medium only, because in the question we have been asked about alkaline medium. So it will be ZnAlO2 plus 2 nascent hydrogen. So these are the basically reactions where nascent hydrogen are given out as a byproduct. So out of these, aluminium and zinc are there in option A. So option A is our correct option. Okay. So the question 10 is, which of the following is radioactive? Now the options that are given, basically hydrogen, deuterium, tritium, these are all the isotopes of hydrogen, right? So the correct option, this is again a very straightforward question. Out of these 3 isotopes of hydrogen, tritium basically shows radioactive character. So tritium is the correct option.